Hi, this is Al Sang, CTO of Strongloop. Today we're going to talk about isomorphic JavaScript at work. I'm pleased to announce a use case that we've developed directly into our framework called offline sync and replication. A quick intro about Strongloop. So we were founded back in 2013. I'm one of the co-founders. We're one of the main contributors to the Node.js project. We wrote a good majority of the features in V12 that's coming out, such as cluster round robin, multi-context, and we actively contribute in the NPM rich ecosystem of modules. We've built an open source Node.js framework called LoopBack, and in the spirit of eating our own dog food, we develop products on top of this framework. So let's define what we're going to talk about today. This word isomorphic. Iso what? It comes from the Greek word isos and morphe, equal or in shape or form. In math, you're talking about a one-to-one correspondence between two sets to establish sort of the equality. And in biology, you can think of it as it comes from a common ancestor. The way I like to characterize it is, for all intents and purposes, or a subset of those intents and purposes, it's the same, but not necessarily equal or identical. So it'll serve the same purpose. So examples of this are, for example, you have Roman numerals versus the Arabic numerals, right? Same thing, just represented differently. So let's apply this to isomorphic, what isomorphic means to JavaScript. In a nutshell, we have JavaScript running in browser as we know it, and now we have JavaScript running on the server, otherwise known as Node. And this goes beyond the notion of what other folks have called full stack, including myself in previous presentations. I like to think of it as blurring the lines between the two because it's the same JavaScript, same again being isomorphic, being run on both, not a flavor of JavaScript with a different API, a different set of the libraries, so on and so forth. So in other words, you can think of it as isomorphic JavaScript is full stack JavaScript ++, sharing the same components, code, API, reusing as much as you can in the spirit of DRY on both browser or server. And to take it into one step further, it doesn't even matter what you're talking about from browser or server, client or server. It could be from server to server or machine to machine as well. It could be from device to device. So for us at Strongloop, isomorphic JavaScript has been a goldmine of enablement. And I'll walk you through sort of the evolution of what it's been able to give us so far. So the first thing that everyone's been able to enjoy with this paradigm of full stack JavaScript is sharing of component definitions, which is what are my models or objects? In LoopBack, we call these models. And that component definition, we're harnessing the power of just being able to describe them at sort of a DSL level with using just JSON, right? So I have this notion of models. So on the browser, we have the definition of what models are. It's same within the MVC paradigm as what you would see on server. And the definition is shared through that common JSON. And that's where we started this journey around isomorphic design. Next, we have shared logic. And I'll talk about this a little more and show you a code snippet later, which is depending on where you're running that code, whether it be client or server, again, browser or machine, I would want to invoke that same behavior seamlessly as if it were running on one or the other. So an example of this would be if you're doing a geo lookup, you're getting the coordinates from your GPS device, from your smartphone. You don't necessarily want to have to cross-reference all of the other locations you're interested in. You would want to send that to a backend service. So you could use a method called nearby, for example. And that's exactly what we've done within our geolocation capabilities within LoopBack. You're able to specify a nearby function on the client and invoke it on the server as if it were handled on the client. And if you ever did want to run it on the client, you could. You have that flexibility. Next, we get into what about the views, right? So this has been a trend that you've seen in other frameworks like Airbnb's Render. We saw this with Dust as well, so you're able to compile JavaScript templates that are rendered on the server versus rendered on the client and sort of blend the two so that you have the optimization of being able to serve it up on server side if you need it to update it dynamically, or client side because you want the responsiveness, snappiness of your application. And finally, what we've done is, what about the data now? With all this code, you have the views, you have the logic, you have the models. Now you actually need the data. And our first foray into applying isomorphic beyond what it's been intended to use is being able to do this on an offline sync use case. So let me walk you through the use case. We have offline tolerance for the smartphone. And this is a key thing that every mobile developers face. You can't assume that you have network connectivity at all times. You have the browser, and it could be a hybrid application, but it could be mobile web. With the advent of HTML5, you have this thing called local storage, which you can persist your data to within this so-called cache or local storage. And you're talking back to the server when you get back online. You have this data synchronization, and for the purposes of the demonstration, we're going to show this as a one-way demonstration. And you have conflict resolution, so that what if you were to update that same record on the server versus the browser while you're offline? What do you do when the two records clash or collide? Let me walk you through the high-level design. So on the left, you have the browser. On the right, you have the server. We're going to go ahead and create several records. The records within the framework are going to trigger what we call a change set. And this is sort of like a journal or a log as to what we're doing as far as transactions or changes of these records that we create. We're going to call on the API on the model. The model is going to be a to-do model because the application, as you'll see, is the MVC to-do app, which everyone's familiar with. And it's going to call a save. The record then is going to be saved to local storage using our framework running in the browser. And that's a key thing, is we've been able to get our framework to run the same as if it were running on the server as it is in the browser through some packaging magic. That change set then is going to call upon another method, and it's going to call a replication, our replication API. So you'll see the naming conventions here, and we'll go into this a little more, but from where I'm standing on the browser side, we're calling a local to-do to replicate to its target, a remote to-do. And you could do the same thing. You could be on the server calling a remote to-do, which could exist actually on the browser. That's another thing that you'll find about isomorphism, is that you have this sort of mirror image of targets, or local versus remote, of APIs running on browsers versus servers, but being the same. I'm going to call the replication API, which is basically going to send that change to LoopBack running on the server, which then is going to create the same record and, using the same API, save this to its persistent store. So it's the same API, but it's storing it now to Mongo instead of HTML5 local storage. So what you'll immediately notice about our sync mechanism is that it's not between the two persistent stores as other mechanisms have in the past, of being able to be tied to your PouchDB or CouchDB or your SQL Server replication. This is at the higher level application level, so that you can bridge heterogeneous data sources. Okay, so let's go ahead and look at the application for the demo. As you can see, it's the to-do app. I'm going to go ahead and I have this running within the browser. I also have a backend instance of LoopBack running on the server. And I have Mongo running here too. So let's go ahead and put in some to-dos. Walk the dog, feed the cat, fly the bat. And because I'm online right now, as you can see, connected, this is replicating to Mongo. So again, it's calling the replication API, sending the change set, and LoopBack running on the server then is processing the change set and writing the same records. I'm going to go offline now to demonstrate the use case we talked about. So let's add a record, ride the donkey, and we have this debug page here, which basically shows what's been going on in the browser. So this change list is what you see that's actually being changed within the browser. Here's the local to server deltas, or the changes that have not been replicated yet back to the server, as well as what's currently being stored in HTML5. Again, if you look in Mongo, you have the 3 records, but not the 4th record of riding the donkey. If I go ahead and connect now, you'll see that it replicates to riding the donkey. Great. Now we're going to go ahead and illustrate the use case of the conflict resolution. So first thing I'm going to do is grab the ID of the record that I want to modify. So let's go ahead and do this. And with my curl statement that I have prepared here, I'm going to go ahead, and what I'm doing is issuing a put against the server in LoopBack and modifying the record, the dog record, with the ID. Let's go back to Mongo, and you'll see that record 8790 has been changed as walk the Doberman. I'm going to go ahead and disconnect here, change it here to walk the husky, and I'm going to go ahead and mark it complete. So upon reconnecting now, you're going to see that I've run into a conflict. So the record here, walk the Doberman, walk the husky. What we provide is an API to do the conflict resolution manually, or we have policies that you can specify, like use local server or use server versions, and you can specify what these policies are programmatically. In this case, for the demonstration, I'm just going to go ahead and use the UE and call this walk the dachshund and use this version. Let's go ahead and confirm that the merge has happened. So yes, on HTML5 local storage, it's been changed, and here you'll see that it's been changed on the server. So that's the demonstration. Let me go and go ahead and walk you through some elements of the code to show some of the isomorphic elements. So the first thing I want to show you is the client code. So this is our JavaScript that's running within the browser, and as you can see, the first thing that I want to point out is the model definitions that we talked about, the to-dos, are the same definition both on the client and server. Models here being extended, being referenced as both remote and local. So the remote instance being on the server, the local instance being on the browser. And all that's happening on the browser is that we're calling this sync function, which basically then replicates both remote to-do to target and local to-do to target. The second thing I want to show you is the actual model definition itself, right? So this is the model that's being shared between client and server. And as you can see, for example, here's a stats function. And this function can then be remoted. So this is our method signature to show that this is being remoted, it can be invoked, and in this case, over our RESTful interface. So as an example, I can go back to here and I can actually call from browser to server and get back this instance. And again, I can call stats, and this would dynamically do this against our REST interface. Lastly, then, is the conflict resolution. So this is a lot of code, but what's basically going on is that it's sending its change list, calling upon to the server saying, do a difference calculation here and send me back the deltas. And let me figure out what the deltas are in the resolution, and calling upon the controller to do the resolution manually. I was able to set the title to whatever I wanted it to be and resync, which basically then resolved the conflict. And that's basically it. So a little bit more about the replication in detail. A change basically consists of these elements. We have a timestamp, and what we do is we go by the old version versus the new version. And the versions itself are basically GUIDs that are hashed upon the values of that within the record. And that's how we figure out the change detection. We also have a unique object ID, and we also specify what the change type is so that the user knows what they're doing. Optionally, we have a time to live element as well, so that the change can expire on its own. Our replication API is a Node API with its REST counterparts. So for example, I can call get my model changes and get back the changes that have happened on the server or on the client, depending on where you're running. The conflict resolution is the same, so we have source versus target, and again, this is independent or isomorphic against where you're running, whether it be on browser versus client. Your source is relative to what your point of view is, and you're able to then resolve what the conflict is between the two by comparing the values of what source and target need to be and setting your conflict model to being that change. And finally, being able to resolve the conflict by posting in what the diff is. So in conclusion, what's so special? So the isomorphic design, again, highly consistent. We're reusing code, makes the learning curve easier. We're able to maintain this over time. You don't have to get your head around, is this code running against the server versus running the client? For us, it's the same framework. It's LoopBack running within the browser versus the server that we accomplish this. And again, we use the same model definition for what the to-do was, and I showed you the JSON representation of what the to-do is. And it's the same API for doing the save. It's the same API for doing the replication as well. And the data abstraction that we were able to harness within LoopBack allows us to do that save against HTML5 local storage versus MongoDB and not even worry about what the underlying persistent store is. The offline sync itself is what we call heterogeneous across data sources. So in this case, it's from device to server, and we're able to do the synchronization, but there's no reason why we couldn't apply this in another scenario of machine to machine, for example, from Oracle to Mongo. And because of the API that we've developed, we give you the fine-grained control, that flexible API to be able to do when you call the replicate and how you do the conflict resolution. So what's next? Run the example yourself. There's a GitHub link there. Check out more about our isomorphic framework known as LoopBack. We're moving more and more toward this model. Our rich set of docs will get you started on being able to do something like this yourself. And we have a lot of content that we think is useful for developers that are developing on Node, as well as the stuff that we've done on LoopBack.